Happy Friday, digital world. We are here again today to answer some more very exciting questions about assignment 2 of the Data Viz module. I can feel the excitement in these questions, and I hope that excitement comes through as I'm reading the questions to you through the digital media. The first question is, hi there, I've seen your last video, which was very helpful. Good, that's very good. I've managed to export the data into a CSV file, but it only contains the vector fields. I've done some digging on ParaView, the software that I want to use, and I have found that if I want to use a CSV file with this software, I need to create columns for the spatial data in order to produce a volumetric visualization, ? You've only discussed creating vectors within the dataset, not spatial positions. Can this be achieved with GenSally? The short answer is yes. So you do not have to specify the positions of the data samples explicitly. And what do I mean by that? So I've tried to draw an example here. These are our data samples, right? This is the first data sample, the second data sample, the third data sample, the fourth data sample, right? This is along y equals 1. So y is pointing this way, x is pointing this way. Now the position, because the data samples, you want to create data samples in this order, in a rasterized order, from bottom left, for example, moving right, and then moving up one row, and then keep going. It doesn't matter, as long as they're in order. You just have to get your coordinate system right, but you don't want to generate random data positions. You want to generate them in an ordered way. For purposes of explanation, I've drawn them the coordinate system origin down here. X is pointing this way and Y is pointing this way. This is just for illustrative purposes. It might not be that way depending on the software you're using. Now, if I want to determine the position of this sample, all I have to do is take the index, for example, the x index of this is 1, and divide it by the max or the maximum x distance, right? So the x position is just the index ix multiplied by dx divided by x max. Now what is dx? dx is just the unit distance between all the samples along the x direction, right, which is usually 1, right? Conceptually, it's just 1 unit distance. But if I want to explicitly find out what dx is, I just take the number of samples and I divide it by x max. So this actually should be the number of samples along x. And that gives you your dx, right? And then your spatial position along x for any sample is just the index. For this first one, it's 1 times dx divided by x max, and there's your x coordinate position. For this position, it's 2. ix is 2. Right, so it's 2 times dx divided by x max. That's the x coordinate. The same is true about the y coordinate. So in this case, it would be iy times dy, which is the spacing between positions along the y-axis, divided by y max. Now, if you want to make your life simple, which you do, you want x max and y max to be the same thing, and you want dx and dy to be the same thing, because you want a square. You want a square volume, right? Square from along the x, y, and z axes, right? You don't want to create some irregular volume. So this is an example of implicit spatial positioning. So it's not given explicitly, it's implicit, it's implied in the space, in the index that the data is given in the CSV file, or the index that you output the data samples and the order in which you output them. So usually you just specify the data samples, and then you specify X max, Y max, and Z max, and the software will automatically lay them out on a 3D Cartesian grid. So I hope that helps. I've made the explanation more complicated than it actually is, but I hope you get the idea, right? I hope that helps. Secondly, is exporting to a CSV file sufficient? What I mean by this is, should I export to a RAW, a VTU, or a VTK file instead? I have done this previously and the output has been non-existent. I've followed the ParaView wiki and still have had no success, maybe because I'm unsure about the layout of the data. Well, I hope that this explanation about the layout helps. Is it 8-bit, 16-bit unsigned data? What's the data byte order? File dimensionality, data extent. These are the things that are required to have a successful output. Now, I cannot give you the answer to these questions explicitly, because then I would actually be doing the assignment for you. However, I can tell you how to find out the answers. So for every software package, they're going to have an input file format specification, and most of them will support CSV file format. So for example, you may remember I mentioned the VTK, and it's mentioned in the assignment. Well, here's the book, right? I'm very old-fashioned. I like to look at books. I like to pick up books and read them and turn to like the instructions on file formats. Here's another great book. It's called the VTK User's Guide. And I can open that up to the index and turn to file formats right there. And there are lots and lots of pages. It looks like the camera's having trouble focusing. Lots and lots of pages on file formats that I can look up here and just, find out the answers to these questions. Now, you might not have a copy of that book because you're not as, cool as I am. But there are PDF copies of this book. Google knows exactly where they are. So you can just Google VTK User's Guide PDF. It doesn't really matter which tool you use, right? Here's the same thing for ParaView. I just checked, there's a digital format of this book on there, and I can open up and I can turn to the pages on file formats, which are the camera is having trouble focusing on, I can see, but you'll have to believe me that that's a section on file formats that you can look at to discover the answers to your questions. Okay, that's the first two questions. Hi again, I have another question about my code that Sally generates. When I run it in terminal, I have to select arguments that generate the points along the X, Y, and probably Z axis, as well as time constant, which would be 1. The higher arguments, for example, 500, 500, 500, the longer it takes, the larger the CSV file, which inherently takes longer to import into ParaView, which I'm still having issues with. Or when I change the output file to RAW, it equally takes a long time. Clearly I'm doing something wrong because I don't believe that it should take this long nor provide such a poor output. Okay, I guess I'll finish reading it. I've attached my code hoping you could say yay or nay, as well as a screenshot of the raw data imported into TomViz, a sister software for ParaView, which looks nothing like what Sally is supposed to look like. I know you're facing a mass of emails from students like myself, but at this rate I don't think I'm going to be able to complete the coursework. and would love some feedback on the code and images. So you're right when you say the higher the arguments, like 500, 500 by 501, the longer it takes. That first 500 that you just mentioned is the number of samples along the x dimension. So you just specified 500 samples along the x dimension, 500 samples along the y dimension, and then 500 slices along the z dimension, which is a pretty big data set. It's unnecessarily big for this assignment. So that's going to be, I don't know exactly how many megabytes that's going to be, but that's going to be, in the hundreds of megabytes, I think. I would recommend, if I was doing this assignment, and I recommend you start with something much smaller. If I was doing this assignment, I would output one slice to start with, and I would output, for example, 16 by 16, and just load it into Excel to see what it looks like. And then I would recommend 16 squared, 32 squared, 64 squared, and 128 squared. Those are the resolutions I would recommend to start with. Once you're confident that those are working and those make sense, I would start adding more slices. So then I would go to 32 cubed, 64 cubed, and then 128 cubed. If you're feeling really ambitious, you can go to 256 cubed to get a really high resolution data set. But 128 cubed will do the trick, right? And 128 squared will also give you some meaningful output just on one slice. Yeah. I've attached my code, hoping you can say yay or nay. I've looked at your code and I can see what you're trying to do, but actually I wouldn't do what you're doing. I would do what I mentioned in a previous video, I think the one just previous to this one. I would simply print out the x, y, z, and time components for each vector. I would simply print them out, and then you add a comma after the time value, so that and then you can you redirect the output, and you can generate a CSV file directly from the printfs in the code. I mean, that's what I would do. It's a really, really easy, quick job that only takes a few minutes actually. And you can generate a CSV file of the data using those different input parameters that I just mentioned. So in other words, I think your code is making the matter a little bit more complicated than it needs to be. So next question. Dear Bob, I have been working on assignment 2 for CSC M37 and I've been playing around with the transfer functions on a direct volume rendering of the walnut data set. Good. I have rewatched the lecture on transfer functions and I was just curious as to whether changing the transfer functions to view the different surfaces is more trial and error, or is there a technique? I have got the volume visualization that I want, but I was just playing around with the transfer functions until I got what I wanted. Is this just the way it is? So I have two answers to that. The first one is yes. I'm hoping that you play around with the transfer functions and explore how they work. I'm hoping that happens. That's part of the assignment. There are ways to make it more automatic, and that's using the 2D transfer functions that we mentioned in the class on ray tracing. So the 2D transfer, gradient-based transfer functions automatically look for high gradients and then assign high opacities to those high gradients. That's a semi-automatic approach rather than having as much, say, exploration as a 1D transfer function, for example. Also, as I am using the Walnut dataset, they have an explicit direct volume rendering, and then they also have an example of a 3D visualization with 3-axis aligned slice viewers. It shows the walnut as a whole in 3D and then shows 3 different slices according to the 3 different axes. I've been watching your other videos of answering questions, but I just wanted to double check that using these were okay for the assignment, considering I didn't explicitly use the software to create the visualizations. They are example from Voreen. So the answer to that is no. You cannot just use the visualizations that somebody else generated. You need to actually run the software yourself and generate your own images. That is part of the assignment, and I hope that's very clear. The other thing is, I have noticed in past years students who simply use other people's images or ones that have already been generated. Now, for a pro like me, it's very obvious when somebody does this, so I don't recommend it because you won't get points for that. I can tell when an image is done by a professional or a student. And it's very easy for me, and it's very easy for anybody that has been doing this business for a while. So please generate the images yourself. Stay safe. Take a screenshot of the whole software, not just the image, but the user interface too, so that you can demonstrate to me that you use the software to generate the images yourself. Dear Bob, there doesn't seem to be a marking scheme for A2 like there was for A1. Is there one available? That's an easy question. Yes, it's available on Blackboard. And it's in the same file as the assignment itself. It's not a separate file like it was in assignment 1. And also I handed it out in lecture, so it looks like you missed the lecture where I handed out that assignment. I hope you watch the lecture on YouTube. Good, I hope that helps clarify things. I'm getting some positive vibes from these emails. I can see people are making progress and really working hard on the assignment, and I like that. And I hope that these explanations help a little bit with the assignment. And I'm looking forward to the next